So my name is Major Hayden. I work for Red Hat, and I'm going to be talking to you a little bit today about RAG. If you don't know what RAG is, you don't know what an LLM is, that's totally okay. We'll cover that. My talk is more focused on people and process, more than the technical stuff, but there's plenty of technical stuff in there. And so my goal is to talk for about 20, 25 minutes, open it up for questions after that, which I think there's like 10 minutes left for questions. And if you want to talk about more, we can go out in the hall. So the agenda for today, we'll do a quick refresher on what is an LLM and what is RAG. Not in like what is the nuts and bolts of all this thing, but what does it mean to us? Like what is the value that we have? Then we'll get into the fellowship of the RAG, and a few of you will probably start to figure out what the theme of the presentation is going to be. Who knows what it is so far? All right, the rest you'll figure it out in a minute. All right, we'll get into the minds, which is the really fun part of working on RAG, and then we'll get to an end where you build a sustainable process that keeps going forward. All right, more of you will start to get this as we go along. So what is a large language model? A large language model is trying to give you something that sounds like the right answer. It's not a knowledge base, it's not an API, it's not comprehending what you're asking it. It's trying to ingest the tokens that you gave it and give you the most statistically probable tokens coming back out on the other side. So it's trying to give you that answer that sounds right. And it's not always going to be deterministic. Under some situations, certain configs, you can get it to be deterministic, but a lot of times it's not going to be. And so one of my coworkers, Sam, sent me a link to this post or toot on Mastodon. I don't know what they're called right now. But he talks about a professor saying that his students are very surprised when they find out that the answer that they're getting is what sounds correct and not really is correct. And that's what an LLM does. So to break it down for humans, an LLM is like an intern with an unknown set of biases that will never learn anything new, that was trained by people you never met on a broad, unknown set of topics, and then you put that intern in front of your most valuable users. That is an LLM. It's also tremendously exciting at the same time. So you might be thinking, okay, well, how do I raise the odds of a quality response for my most valuable users with information that changes over time? And when I say changes over time, your information will change, like an existing document will change. New documents will come in. Old documents, you'll say, oh, we don't need that anymore, or it's inaccurate, or it has problematic language, or it needs to be revised, whatever it happens to be. So RAG is a tool that can help. So RAG is retrieval-augmented generation. It's a three-step process. The first part is retrieval, which is exactly what you think it is. You have a repository of knowledge. You retrieve knowledge that helps to answer a question. Next, you take that knowledge and you augment the user's original question or their concern or whatever that happened to be, and you add this context to it to help answer the question, to get a more complete and coherent response. And then finally, at the end, you take that knowledge that you've retrieved, you take the original question or concern or whatever came through there, and then you provide a set of instructions. If you heard people say prompts or prompt engineering, that's a set of instructions that tell the LLM, hey, when you handle all of this information, here's how I want you to talk to the user and think about this information. So on a graphical level, if you go to chatgpt.com or you go talk to Claude or you're using VS Code and you're asking a question of GitHub Copilot, wherever you are, you're talking to an API and you're sending a question. And some context may be going through there, maybe like a file that you have open in your editor or something like that. That all goes into a RAG system to retrieve information that will help answer that request. So it takes the original query, a little bit of the context that you had, and tries to find matching documents. And then out the other side, the API system will then do that combination step, the augmentation step. Take the question, take that context that it pulled from the RAG database, and a set of instructions in the prompt, and send that to the LLM. And if all goes well, the user receives a correct, complete, coherent response. It's not always the case. And so Mo Duffy on my team gave me this analogy, and I love it, that RAG is a lot like an open note exam at school. So this is a difficult exam you take in college maybe, and your professor says, hey, you can bring your notes. And you're like, oh, sweet, I can bring my notes. Have anyone gone to an open note exam where you haven't studied enough? So here's the thing. If you know the concept well, but you're like, hey, what year did that war start? Or who was the one who wrote that poem? Or, you know, you're doing a calculus problem and you're like, hey, is it a negative x on the top or a plus x? You can go in your notes and find that quick and then go solve the problem. But if you didn't study the calculus and you hit the exam and you don't know what a vector is and you're doing vector calculus, no amount of notes are going to help. It's the same with RAG. So If you haven't figured it out now, you're probably going to figure out what the theme of the presentation is. So someone said that RAG was going to be easy, but it's probably not, so you better be careful. So this is where we start with the Fellowship of the RAG. How many people have read Lord of the Rings or seen the movies? Okay, if not, I'll try and explain some of the references, but you might have to ask some of your friends afterwards. Okay, so it all starts with all your documentation system lives in a hole in the ground. In Lord of the Rings, this is the Shire. It's where the hobbits live. They're very cute little people with giant feet. They eventually go on some amazing quests together, and I'm doing a horrible summary of the book. But this is the idea. You have lots of documents in a RAG system, and you say, well, wait a minute, let's just put these into an LLM, and then we can help all of our customers answer all the questions that they have. But it turns out to be difficult. The hobbits start down the path, and they're like, oh, man, this is cool. Like, we're hanging out as friends. It's good. And all of a sudden, these black riders show up that look kind of like half ghosts. They get these creepy fingers. And that's exactly what happens when you start messing with RAG. So it all starts with the senior engineer, which Dan Walsh reminded me I'm becoming one of these, so I need to be preparing myself. So these are the people that are asking, hey, what data do we put in? What data is allowed to be shared? What data is allowed to be shared with which users? Which data can never be shared? How are these things being tagged? So they're setting up everyone else in the group for success. Then you've got junior developers. They come in and they're like, hey, wait a minute, where are these documents? What format are they in? What audience are they written for? Are they written for a highly, highly technical audience? Or are they written for an audience that's just getting started? Are they accurate? How often do they change? And there's a great quote down here that I feel about the documents I work on at work, where Bilbo says, I don't know half of you half as well as I should like, and I like less than half of you as well as you deserve. It might take you a few minutes to think that through, but this is how we all feel about our documents. Whether you're at a company or you're at home dealing with your own documents, it's always the same. Then you have a quality engineer, so Samwise shows up, and they are coming with you, and they're like, I'm going to see it through till the end. This is absolutely insane. Too much stuff is changing all at once, but I will come and help you test this non-deterministic system, and we'll all enjoy it together. And then finally, and I know we all have some of these. Some of us are fortunate to have more than one of these. You have an AI enthusiast somewhere in the organization. They are excited. They read something on Hacker News 12 minutes ago, and they want to tell you all about it. It is the new rage. You must hear about it. These people are amazing because they keep you excited. But you also have to kind of keep them under wraps a little bit and make sure that they're giving things to you in a way that you can understand them. So with all of this, the perfect solution is the enemy of progress. So you'll make progress. This is a quest. That's the reason why the Lord of the Rings reference. It's a quest. It's not a destination. You'll find, I don't want to give it away, but they do make it to Mordor at some point, and some other stuff happens after that. So it is a quest. Okay, so now we get into the mines, which if you've read the first book of Lord of the Rings, the mines of Moria are a very interesting place, and then for some reason in the movie, they take 5 seconds to get through. I don't know what was going on there. Okay, so your best place to start is with the user story. Find out who are your users. What do they want? And when they get that, what will they then be able to go and do with it? This is a great way to get everyone from product managers to engineers to quality engineers to marketing people, everyone on the same page because they know who they're delivering to and what they're delivering. So someone internally might say, hey, as someone who does support, I want to be able to find answers quicker so that I can answer customer requests faster and get to the harder things that need to be solved. External users might say, hey, I want to search for things that help me troubleshoot an error message. That then allows me not even have to open a support ticket. I can go fix it myself. My boss will be super happy. And then after that, you align the stakeholders. And so you start to think about, hey, who are these end users and what information is the most important to them? Like, what are the information pieces we need to find first? When does it need to be ready? What is the budget that we have to work with? I know my boss hates every time I come to him and I say, hey, what if I push the budget by just a little bit? Would that be okay? And he's like, what am I getting out of it? And so having these conversations is good. And then how do you measure your success? Measurement becomes really, really important. And then as you get started, you start to stumble. Anybody remember what this scene was? Was it Caracas? I forget the name of the pass. I don't know. It was terrible. So documents are very easy for humans to parse, but it can be really hard for computers. There's a project from IBM called DocLink that's really cool that gets everything into a common format that will allow you to work with it. You got to pick an initial method for searching, which I'll get into in a second, and then always score your results. Know if the changes that you're making are making things better or worse for your existing questions and new ones. And keep your changes small and demo to your team a lot. That's one thing we do within my team is we demo usually every 1 or 2 weeks and show off some of the things that we've done because it gets everybody on the same page. But then the AI excited person shows up and they're like, oh, there's a new Hacker News article. And you're just like, okay, send me an email, put it in Notebook LM, do something, like I'll take a look at it in a little bit, but we're on path. So the search strategies. There's 4 main ones that I've run into. The first word is keyword, or you hear it called lexical search. And that's where you're going to match an exact string. That could be a single word, or it could be a turn of phrase. This is very useful if you have product names or places or commands or things like that that are very unique. But it will miss things like in the US, we call it a truck. In the UK, they call it a lorry. It'll completely miss it. Or car and automobile will show up differently. And that's where semantic search comes in. So the vector search actually allows you to get more of the meaning of the words that you're looking at. So it takes a string and runs it through an embedding model and gets a series of vectors. So it gets coordinates on a plane. And so instead of combining sentences and saying, do they match, 0 or 1, now you have a 0 to 1 relationship. So you'll know what level of similarity you're working with. Graph or relationship-based stuff will allow you to group things together based on a particular topic. So if you have a product, you can group things together on that. Or you can say, let me get documents that are security related across all my products. And then you kind of bring those together, and that's what you use for your searching. And then finally, you can put some of these together. For example, keyword search and vector search you can put together. So you get the best of both worlds. You get a little bit of that extra emphasis from the meaning, but yet you'll still match on those keywords. Or you can use keywords to drill down and do an immediate filter, and then use the semantic search on what's left. So semantic search has challenges. And this is when they first went into the mines of Moria and discovered that what they thought was going to be there was not there. And that's what you get with a vector search. So the challenging thing here is that you can't take your entire document and jam it in an embedding model and call it a day. The embedding model has a context window, and you can't overflow it. Otherwise, you won't get, none of that will be indexed. You can't search it. So there's 2 steps. One is called splitting, and the other is chunking. So splitting is when you break something up based on what a human would recognize. Maybe it's a chapter break. Maybe it's a page break. Maybe it's a topic change in a document. Or maybe all of your documents are like legal documents, and they're all structured the same way. These would be the places where a human would split the document. And then from there, inside of a split, like if you have a chapter 1, you'll do a chunk of a certain size. Some people do it based on words or letters. Sometimes they have a little overlap between their chunks. But this is where the scoring gets important because you can change your chunk size, change your overlap, and then see how the data gets better or gets worse. And then you get the AI excited person, just put the PDFs in the bucket, we're going to launch today, and you have to say, no, we're on the path, and there's a reason for that. And you'll reach the final boss, which, does anybody remember what the monster was called? The Balrog, yeah, okay, it's really creepy in the movie. I think it's creepier in the movie than the book. But this is where you hit a 10,000-page PDF written 15 years ago by someone who's no longer at the company, and you're like, oh, but it's all just text. And then you find out it's scanned text. It's all like bitmap, PNG type representation of text. And now you're OCRing 10,000 pages of text that have graphs in it. So sometimes you just have to say, you're not going to parse it. And that's okay. And there's some ways to get around this. So you have to keep the end goal in sight. When you hit these documents, put them aside and know that you can reach out and ask for help. So if you have teams that own documentation within your group, you can push that to them and say, hey, I want to include this. This is really good information, but I need it split, or I need it updated, or I need it changed, or do you have the original copy, or how do we make this better? But the most important thing is in the 5th spot there, is garbage in, garbage out. No amount of RAG strategery will work if you're putting garbage into your RAG database. If you put in information that's not useful or invalid or unhelpful, then those are the results you will take out at the end. So sometimes you'll run into some failure scenarios as you add documents. So sometimes you get an incorrect response. So for example, you ask a question about a history of Apple computers, and instead you learn about apples that are grown in Washington and their fiber content. Okay, Well, those are both useful bits of information, but they're not relevant. And so sometimes you'll get something that's correct, but it's incomplete. As I know this is Ellis's favorite, I came up with the beef Wellington problem, where it's a very complicated recipe with many steps. If you get steps 4 through 8 of 20, that's correct, but it's incomplete. There's a lot of steps to making that. If anybody watched Hell's Kitchen, with Gordon Ramsay screaming at people about it, yeah, if you miss a step, boy, he will find it immediately and start screaming at you. Hallucination can also happen. I'll talk about that on the next slide. And then finally, sometimes you'll get something that's correct but irrelevant. So for example, a user says, how do I change my password? And they get instructions on how to create a secure password. Okay, it's useful, but that's not really relevant to what I want. What I was looking for was like, what are the steps I need to do to reset my password right now so I can get back into this system? So hallucinations are a challenge. And this happens when, if you go back to the beginning when I was talking about when an LLM replies to you, it's looking for the most statistically probable answer to what you said. And sometimes you get to the edge of its knowledge. And when you do, the LLM does the exact same thing that my kids do when I catch them doing something they're not supposed to. And I say, what were you doing? And they start rattling off this long string of stuff. And I'm like, you really did it, didn't you? Yeah, I did. Okay. So LLMs are not good at doing that. They will just keep going. And so sometimes you have to find a way to improve this. And I'll show a couple of ways to do that here in a second. And so the model size matters here. So a lot of times you'll look at a model and it'll have something B on the end, like 4B, 8B, 20B, 120B. And then you'll notice if you ever want to have out-of-memory errors, just pick up the one that's got the higher B numbers, and it's really fun to run on your system. So sometimes the type of model that you choose is very important with the RAG data that you're using. So if it's a small model, you'll want to make sure that the training data is aligned with the data that you're trying to do. So for example, if it's trained only on English and your customers are going to be asking questions in Portuguese, it's not going to work. If you're doing very highly technical, scientific related things and your LLM is trained on Shakespearean novels and things like that, it's not going to work. So that's where you can reduce the chances of hallucination by adjusting those models. Large models like some of the Llama Scout models, and then the frontier models like that you get from Anthropic or OpenAI, those you don't really have to commit as much work to RAG because there's such a huge training base on those. All right, so at the end, The Road Ever Goes On. Does anybody know that song was sung more than one time in the book? In the series of books in Lord of the Rings? No, the song is sung multiple times for different reasons and in different states of emotion. It's pretty cool if you go back and check it out. All right, so you need to develop a pipeline for improving that context. Because eventually what you'll run into is you'll find a knowledge gap. Someone asks a question, there's hallucination, the answer's not right, and you'll say, okay, how do we fix this? So you'll try and go find those documents that can be added to answer that question. You'll ingest them, you'll score them, and you'll say, hey, wait a minute, did this improve something or did it make it worse? And then it's a really good opportunity to stop and say, hey, wait a minute, is this document a good quality document? Is it accurate? Does it have the right keywords? Could we just rewrite it a little bit and have it better? Could I have an LLM extract the most important information out of this document and then try to put that extraction back into the process? So eventually, every time you do this where you want to update something new, it's awesome to have a scoring process to know if this is working better. And so you'll eventually make it to the point where you're done enough, where you'll say, look, we can answer maybe like the top 10 questions that our customers are asking us, or we're experts on the top 5 topics that we care most about. This is where you'll get to that point where you say, look, our quest is not done, but we're so far along now that it's time to put this in front of people. It's time to get some testers, and it's potentially time to go to production. So when you do the production deployment, it's always a little bit scary. And there's a quote here on the left that's pretty good. It says, but late in the night the watchman cried out and all awoke. The moon was gone, stars were shining above, but over the ground there crept a darkness blacker than the night. On both sides of the river it rolled towards them, going northward. This is what it feels like to deploy to production for the first time, doesn't it? Anybody? Yeah, people are like, oh, I use Kubernetes. I deploy production all the time. And I was like, what about that first time? And they're like, oh, I remember the first time. So the two most important things here is do your absolute best to log the original query from the user, the context you got back, and what the LLM said. Because eventually you'll get a bug report and someone says, hey, I asked about this and I got this. And it allows you to go back and say, hey, wait a minute, was my context wrong and that messed up the LLM? Or did I not have context? That messed up the LLM. Or then be able to say, hey, no, the correct context came back, and the LLM just made a huge mistake. And so then the question there is, do we have the right LLM? Is it trained on the right data? Do we need to go to something larger or something different? And the last part there is build a method for people to submit feedback and make sure you're getting the right information from them. It's also an awesome opportunity. If you have people within your organization that hate AI, I know all of us probably have some of those, to be able to say, hey, did we give you the wrong answer? And they're like, oh, yeah, you did. And I'm like, well, where's the right answer? Well, it's right there. And I'm like, thank you very much. And then I look at that as the next candidate to go into the RAG database. So it's one way to get people engaged that maybe don't like using AI-related things. So we've recently built a product called Rel Lightspeed, and there's a set of lessons learned that at least I know have impacted me quite a bit, and if I could start over again, these would be things that I would think about. So the first one is that it's not a destination, it's an ongoing quest. It'll never be perfect. LLMs are constantly changing. The field is constantly changing. As you saw from Rob's presentation this morning, it's just every time they hit a roadblock, they find a way around it and change the way they're doing it. And it's the same thing with RAG. I've seen all kinds of amazing things that people are doing with it these days, where they're having multiple RAG databases through different tools. They're trying to understand a user's intent and then using that as a way to figure out which kind of RAG documents they need to get. And your fellowship matters a lot more than your tech stack. So if you have product management aligned with engineering, and you have engineers aligned with quality people, and you have documentation people that are engaged, you'll have a lot of success. If you find that one group gets left out, like engineering is just going cowboy and changing everything every 10 seconds, quality engineers are going to just kind of be flopping around the back just trying to hold on. It's kind of, it's a difficult place to be. So make sure everyone's engaged and make sure everybody knows what's changing. And the second group of things is start small, fail fast, and learn constantly. And just understand that the first iteration is probably not going to look anything like the last one, and that's okay. It is really important for everyone on the team to understand that failure is okay. This stuff is extremely difficult because it's all about knowledge. You have a system that you don't have a lot of knowledge over that won't ever learn by itself, and you're increasing the odds of success. You'll never get to 100%, but the closer you can get, the better. And if you're measuring everything, you'll be able to know if something is improving or not improving. As long as the number is improving and getting better, you're moving in the right direction, even if it never reaches 100%. Last thing is that the docs quality matters so much more than the RAG strategy you pick out. If you go on the RAG subreddit on Reddit, it cracks me up reading so many things in there where people are like, I took all the 165,000 PDFs from my company and I split and chunked them and I can't find anything. And it's just like, ugh. And then they come to find out that it's a lot more involved. But on the flip side, you'll find people with a lot of structured data. Like I find constantly where people talk about legal data, that they have attorneys that say, hey, I want to be able to search through all my past cases and be able to find things that are similar and use the same arguments. Well, if you ever see legal documents, they have a certain structure. They're rigid. Like the font is the same, the signatures are in the same spot, everything is the same. So when you see other people saying that RAG is easy, that might be the reason. Their source documents are a lot easier to work with. Whereas other ones in other companies, you may have a bit more of a challenge to work through. And that's it. So thank you for coming. And if you have any questions. Sorry, just get some water.
Yeah, take your time. Yeah, thanks for the great presentations. And I have a question regarding the. So if you are using the RAG to retrieve, it will retrieve a list of the related pieces from the kind of databases, right? Do you just equally give them the equal weights, or just give different weights so that we can kind of focus, or we can emphasize more on one piece or give less attention on the other piece?
Right. So the lazy answer is yes, but you get to define how you want to do it. So for example, when you select records from a database, whatever database you're using, if you're doing a hybrid search where you have keyword and semantic, you can have the scores combine and then say, hey, for a document to make it to me, it must be this score or higher. So for example, when I said the semantic search, a lot of times people will use a cosine distance. So if you think about like geometry and angles and things like that, if the cosine distance of two sentences is like this, that means the sentences aren't close at all. They're about two different topics, like what apple is the tastiest and does this rash look bad? Like, it's not the same. But then if you say, hey, how do I wash my car and how do I clean my van? The cosine distance between the two of those is going to be really small. So what you can say is, hey, only give me things from the database that are this similarity or closer. And then what you can do is weight documents too. So if you have documents that are very, very high quality and you're like, this is the best information we have, you can weight those higher in your database so that they will be higher up in the stack when you look at which ones you're going to include when you send to the LLM.
So if we have multiple pieces that kind of are all considered very high quality, should we just concatenate all the results and feed into the LLM?
So you depending on the LLM, you might run into a problem with a context window, and then you run into a problem also confusing the LLM as well. So sometimes if you have documents that are very, very similar, or chunks in a document that are very, very similar across multiple documents,
Yes.
Especially like if you have boilerplate, like just the same text that's on a lot of your documents, pull that out before it goes in. Or once you put the stuff in the document, do a search through the database to see which chunks are very similar to one another, and then deduplicate them. That's one thing that can help.
Oh, so if I understand correctly, there is the steps for before building the database for RAG, which is kind of a deduplications or kind of a remove any invalid content, right?
Right. So, I mean, case in point, we had a problem with SE Linux documentation in RHEL 8 and RHEL 9 is almost the same, but there's some little bitty gaps in there. And so then Ellis and I have been working together to try and figure out, like, hey, how do we deduplicate and pull those out in such a way that we don't lose the information that's different, but then we only keep one copy of the information that's the same? Because you wouldn't want to have like 3 chunks come back and they're almost the same, except they reference different versions of your product, and it'd be kind of frustrating. Does that help at all?
Yeah,
Okay,
helps
cool.
a lot. Thanks.
I don't know who's next. I'll let him pick.
Do we have a general RAG model like that define that for this specific use case, this is the best general RAG model that you can use, or this architecture is best for this specific use case? Do we have that? Like we have different kind of LLM models specific to certain things.
So what I would say is there's a lot of patterns in use out there. What I love to read about is the patterns that other people are using to get access to their documents. Like sometimes you'll find people be like, hey, I used Weaviate and I used this embedding model and all this. But what I'm really looking for is like, how are they selecting their documents? Like how are they splitting them and chunking them? And then when they went to go get them, what are they doing in that step? Like, so for example, we've talked a bit with the DocLink team about expanding context. So let's say we get a chunk of a document and it's super accurate and we're like, oh, this is perfect. How could we then go up and down and extract more of that context that's really useful up to a certain point? So I don't think there's a perfect way. It really depends on your documents and how you're going to search them and what your users are asking for. But I think if you look at the patterns, you'll find a lot more value than looking for like the exact way to do it. Hopefully that makes sense.
Quick question. Great talk.
Thank you.
Have you had any experience working with multi-vector representations? So when you look at call Pali, for instance, when you're looking at multimodal representations where you have like a lot of vectors and then you're maybe using Muvera to compress some of these vectors into a single vector. Have you explored that kind of retrieval paradigms yet? Or have you also looked at deep research into your own code base? Like deep research on ChatGPT obviously scrapes the web, so on and so forth. But you can also do retrieval in your own code base, I'd imagine. Have you done any kind of that kind of pipelines yet?
We haven't gone down that route yet, and I think mainly because we've run into other problems first. Like the beef Wellington problem is a very common problem that we have. Like we'll pull back documentation that helps the customer, but we'll only get back like 3 steps out of 6. And then we're thinking, okay, wait a minute, now we got to solve the problem of I need to get all 6 steps, and maybe some of the context at the front as well. I think mainly what we're doing right now is normalizing the vectors and using half-vec and PG vector just to kind of decrease size and things, but we haven't done anything with like the multi-vector analysis yet. But that's a cool idea.
Hi. So you mentioned about keyword searches and semantic search, right? So we have the same technique, what we are using, and we have a session next for where we use that. But one of the challenge was that when we are doing the keyword searches and the vector searches, the scores, the confidence scores comes back very different ranges. And now we adopted some techniques to normalize or so that we don't discard the results because it's one algorithm is giving 2 low scores, right? Do you have any techniques to how to normalize or give some weights to different kind of searches, search results?
That's a tough one. Okay, so you're asking about like certain searches work better at certain times, and how do you weight the one that's going to give you
Because we were using the Elastic database, right? Now when we do the keyword searches, the scores are in very hundreds or something, but vector searches is like 0 to 1. Now we have to give some normalization, right, so that we are not automatically discarding. So we did some logical algorithms there, but I was curious if you have any techniques to.
We haven't really been that far down the quest yet, but that's a cool idea. Like that's I have seen some things where people have multiple RAG searches that they search simultaneously, and they may even be in different databases, like stored in different ways. Especially if you have like tabular data, like CSVs and Excel files and stuff like that, versus like full text. It's pretty different. I think that would depend. It would depend so heavily on what your data is and which data is the most important. I don't know. I think at that point, what I might look at doing is actually splitting the API that's in front of it. Because I think about it like, you know, if you had a CFO that wanted to ask questions about the financial data within their company, there might be another mechanism where they want to search full text related things. So maybe they want to ask about crunching numbers, about most recent reports, but then also they might want to ask like a full text question about like, hey, I want a detailed explanation from that. And maybe I would have those in two separate APIs. Like the queries would go into 2 separate places. But yeah, we haven't gone that far yet.
Are there any approaches for that similar but different problem? I believe your example was user wanted to create a new password, and it gave an example for how to reset an existing one. So you do a vector search. Those are incredibly similar, but one is very much not the other.
Right. So I think that's the point where the logging comes in handy, because then what I love to do is I go throw the query into a vector search, and I don't have any criteria, no filtering criteria. So I want to know exactly what comes back from the database. And sometimes, like for that particular one, that's an issue that we ran into. And the reason is that the exact documentation that we needed did not exist. And so that other one was popping to the top, and it somehow went just above our similarity score requirement. And so then we kind of identified, hey, wait a minute, there's some documentation we don't have that we really need in there, so that way we get the right answer coming out on top.
Hi, good talk. I wanted to ask, do RAG models have like a bell curve or something? If I provide like too many relevant documents, important, good quality documents, does it have a bell curve that the performance drops, or like model starts to get confused with the excess of data it has been given?
So you're talking about the inference model receiving too much context? Yeah. There can be situations like that show up, especially if the 2 documents maybe conflict with each other. But then also you can run into situations where your embedding model that you're actually using to create the vectors is not good for the type of text that you're working with. For example, there's some embedding models that do English only, and there's other ones that do other languages. There's some embedding models that are really good with like programming languages and embedding text from there, or embedding like the LaTeX stuff, like the like equations and things like that, math-related things. Yeah. So sometimes that is an option. I know we talked about the multi-vector stuff before. Sometimes it can make sense to embed with multiple vectors and then figure out the best ones to use to search the text. But yes, the fewer amount of context that you can give to the LLM, the better. If you could find the perfect one and only give it one, that would be the best.
And lastly, like, is there a way to, I don't know, efficiently find out the quality of documents if I have, let's say, hundreds of thousands of documents? So like, how do I efficiently find out the quality?
Oh, there's someone sitting 2 rows in front of you that would probably love to talk to you more about that. Aaron, right there, is on my team. So I don't have a lot of data science experience, but I think that's an area where someone that does know data science can help you. And I think that's one of the most overlooked parts, is that very first part of like, how do I identify what docs are high quality, especially if it's written by people who are experts in that area and you're not an expert. So for example, if someone's writing about memory management in the kernel, I am not the expert. I can go find an expert, but that's, I have to do that to know about the quality. So that could be an option.
Okay, you can talk to Hayden personally when so we are time up. Thank you everyone. Thanks Hayden for
Thank you.
attending. Yeah.